Now we have seen the LIBOR market model taking this particular form. So what happened if delta I, so we have delta I here, is approaching 0? Well, why do we even ask that question? Well, if delta I is basically the time point between k and k plus 1. Then if delta I is approaching 0, we actually, instead of a discrete forward rate, between a time period of k to k plus 1, this fk then becomes an instantaneous forward rate. Okay, so if that becomes an instantaneous forward rate, this process should be the HJM process. Okay, so if delta I approaches zero and this does not convert to HJM process, something must be wrong. Okay, so we have to demonstrate that as a validity check, this BGM model must convert to the HJM model if delta I is approaching 0. Okay, let's see how that is done. Well, as delta I approaches 0, we see that it actually indeed converts to this. Why? Well, first of all, what's Fk? Well, Fk is really F t, t, which is the current time between a time period t to t plus delta t, because this t will be like a k, this t plus delta t will be like k plus 1, but then you were converting that difference here, you're shrinking this. So this latter part becomes closer and closer to this one here. So k plus 1 becomes closer and closer to k. Okay, so really, then you have, just writing a different notation, you have ft, t is still this t, and this big T is just, this k here. So this becomes instantaneous forward rate. Okay, so we know this part will convert to this. Now, what the process here convert to that process? Well, as delta I becomes, approaching 0, this is just the volatility term for this k, right? Fk. So as Fk converges to Ft little t big T, it becomes the volatility term for this. So the volatility, because this part has become this Ft T. So this part is just a vol. So the volatility of this is by definition this, right? So fine. So this part will become this. Okay, now what some people look at this from here to here and may say, well, okay, we have an Fk here, and when it becomes this, shouldn't we have an Ft F little t big T here? Why do we just have an S here? Well, if you recall that here, this thing is only a function of time. Okay, it's not a function of state parameter, and the state parameter is here. Okay, F is here. Now here, the little s actually it's a function of time and also the state parameter. This omega is basically of all the other information, including state parameter. So this is just a generic form, a functional form. This is a more specific functional form. The product of those two. One is this function is only a function of time, and the state variable is also a function of time. But here, this is a more generic functional form here, which includes this type of forms as a special case. So just and because of you already have this, you don't need to have a fk here. If you just have S, T, and big T, then you will need to have a FK here, okay? Unless you have this been specified in a very specific way that F may drop out. But typically, for a lot of ones, if this S is only a function of time, then you would need to have an F here. But here, this is a generic one, so it includes that as a, so it's already being included here. Okay, now, so we're taking care of this blue part. So what about this drift here? Okay, I know this will just be S, which we have, talked about earlier. But what about this green one? What is this green one, the integral? Well, first of all, if you look at it, as delta I becomes approaching to 0, this denominator is approaching 1. And so you basically left with this part here. And this part is really then becomes the integral here. Okay, so as delta I becomes to, closing to, approaching 0, you basically get a d tau here for the integral. So then is an integral of this. So it's basically as d tau, and this discrete sum becomes integral here. So it shows that if delta I is approaching 0, and we basically have recovered the HJM process from the BGM process, which demonstrated that the two models are consistent and they are related, and so this is a very it's a good validation for the LIBOR market model.